Hi everyone, welcome to Multimodal Weekly webinar series hosted by the team at 12 Labs. We've been running this series over the past, 31 weeks, if I'm correct. We've been doing this series every Friday at 1:30 p.m. Pacific times. And here's some of the topics that we tend to cover on a weekly basis: research in multimodal evaluation models, innovative application of multimodal different verticals, different projects related to multi-role and video, and as well as sometimes guides and tutorials from our internal team about technologies and API. Just to give you a sample of the previous speaker list, we're ranging persona from founders to open source developers to researchers in the space. So for today's session, we'll have two speakers. One focused more on research, and the other one is more focused on open source and startups. So for the first half of the webinar, Lucas Lee, who's currently a research scientist at 12 Labs, will give a talk about his work on video frame interpolation, different techniques to handle complexity and discontinuous motion in video. And for the second half, we'll have Nir Gazit, currently the CEO of traceloop, who will give a talk about open source observabilities for foundation models via the OpenTelemetry format. And I got a chance to connect with Nir a few weeks ago, and they're super excited to see more initiatives in the open source community to basically democratize the utilization and adoption of this big model. So with that, this is a quick logistic note. Feel free to send your question on the Zoom chat as you had any thoughts for the speakers. And then after each speaker finish, we'll have a short about 5 minutes Q&A for any real-time dialogue between the speaker and attendees. So with that, let's stop sharing my screen, and I let Lucas, do you want to get started sharing the screen and go ahead with your presentation?
Yeah, okay. Do you hear me?
Yep.
Yeah, thank you. Can you see my screen?
Yep.
Okay. Yep. Hi, my name is Lucas Lee and Hyungmin Lee in Korean, and I'm from 12 Labs. I appreciate James for the great opportunity to present. And today's topic is actually not more multimodal, but very video topic, I think. So today I'm going to talk about topic I worked on during my PhD, video frame interpolation. And the title is Complex and Discontinuous Motion Compensation for Video Frame Interpolation. So let's get started. This is today's contents, and I focused on two of the many obstacles that make video frame interpolation difficult. So I will introduce the two works from my papers, and they're complex motion and discontinuous motion. So first, I'm going to talk about what is frame interpolation and why I started from this topic. Video frame interpolation is the task of reconstructing the intermediate frame given two consecutive frames. And for images, pixel interpolation can be done by simply averaging the surrounding pixels or something like that. But for video frames, if we just average them, we will get the overlap frame like this. And this is not what we want. This is what we want. So to make this possible, we need to make the model know that the two balls here and here are the same ball. Not the two balls here. So the two balls here and here are the same ball, and this can be known by the model. And this point is very important. This is what inspired me to start studying video frame interpolation, and the Professor Takeo Kanade, famous for his work on optical flow, said correspondence is important in computer vision, and correspondence is I think correspondence is the ability to say that two different locations in two different images are the same, and if they are consecutive frames of a video, this is the motion. This is the motion. So at 12 Labs, I study video representation learning, and this kind of insights are very important for video interpolation, video understanding research. So coming back to frame interpolation task, we should note that the object we want to reconstruct in this example, this is the example of B. So the object we want to reconstruct is present in at least one or two frames, neighboring frames. And so what we need to find we need to find the object from two neighboring frames, and this is the motion estimation step. Then we need to move the found object to fill the frame we want to restore, and this process is called warping or motion compensation. So therefore, most of the recent research is based on passing the two frames through a neural network to obtain some parameters, and the estimated parameters are then used to perform motion compensation. And this is one of the structure. And there are two prime examples of this structure, and the first is called deep voxel flow. And in deep voxel flow, we estimate the vectors pointing directly to the pixels we want to find from neighboring frames, and sample those pixels to fill the frame what we want to restore. And this method has advantage of being able to reference anywhere in the frame, but this disadvantage is that the reconstruction is very unstable because it only samples pixels one by one. And the second example is adaptive convolution. In adaptive convolution, we predict a large kernel for each pixel that can be multiplied by a large weight to find target position and convolve with this kernel to get the frame what we want to recover. The advantage of this method is that it is stable in that it is weighted sum of multiple pixels to restore target frame and target single pixel, but the disadvantage is that it cannot deal with motion larger than kernel size. So to address the shortcomings of this existing method, we presented a paper called AdaCov at CVPR in 2020. So unlike traditional method, AdaCov can reference multiple pixels and any location. This idea is inspired by deformable convolution, deformable convolution, and like deep voxel flow, the AdaCov operation finds vectors pointing directly to the reference pixels, but instead of finding just one, it finds multiple pixels and mix them with weighted summation. Yeah, this is the overall structure of an ADA-CUF network. A simple UNet is used to predict multiple vectors and weights from input frames, and which are they are then used to perform ADA-CUF operations to finally obtain the intermediate frame. And this is the visualization of the parameters and occlusion map and the motion vectors or variance of motion vectors. And this is the input frames. And this is a visualization of vectors from ADA-CUF. And this black point is target pixel, and this cyan and green points are the locations reference to used to reconstruct the target pixel. And so and you can see that the vectors are sometimes clustered together like this, but they are also spread out to allow for different information to be available if needed. And also we can get this kind of optical flow map if we just mean or weighted summation of the this kind of vectors. And we can also get occlusion map here. So this data set has optical flow and occlusion map ground truth. So I compared them in MPI Intel data set, and we achieved state-of-the-art performance at the time in our quantitative evaluation. And this is the result of the interpolation, and the resulting video is uploaded to YouTube, my YouTube channel. But I will share the link to the video, link to the video on the Discord channel after the talk. And the second obstacle is discontinuous motion. And as we apply to our ADA-CUF to various videos, we realized that there are some things in the world that shouldn't be interpolated through motion, most notably chat windows and internet broadcasts. So it's natural for chat plane to bump up discontinuously as chats are updated one by one, but the previous interpolation models interpolate these chats to bump up smoothly as well, like this here, like this. But what we want is some discontinuous motion like this. This is our proposed version. And so the chat window isn't the only example of discontinuous motion. This includes number-based UIs like this, or some blinking objects, or some not moving object, or including chatting windows, something like this. So we wrote a paper that first present the problem of discontinuous motion and introduced some tricks to solve it. And it was presented as a highlight session at CVPR last year. And the first trick is data augmentation. Instead of collecting a new data set with discontinuous motion, we add discontinuous shape figures to existing data sets so that the model can learn discontinuous motion. We call this we call this strategy figure text mixing, and yeah, it is called shortly FTM. And especially we add discontinuously moving figures for tests here like this. And the second trick is discontinuity map. You can see here, the model estimates a map with a value of 1 for pixels that move discontinuously and 0 for pixels that do not move discontinuous, that move continuously. And discontinuously moving pixels, it copies the first input frame, just copies the input frame, not the interpolated one. And this is Ada curve network modified to cover discontinuous motion. This is just Ada curve with discontinuity map here. And finally, if we consider the FTM and the discontinuity map together, we can give the positions of added figures in FTM as ground truth for the discontinuity map. So these three are the proposed tricks to cover discontinuous motions. And yeah, we also collected GDM dataset benchmark. This is the benchmark by sampling clips from mobile game or computer games videos that contain a lot of discontinuous motion. Especially many mobile or computer games contain various discontinuous motion here, like UIs or playing buttons or checking windows. And this is the interpolation of various images taken from GDM benchmark. And you can see that the results for discontinuous motion are much cleaner than other methods. In particular, the first row here is a case of full screen transition. So our model is very robust in this case. And this is a visualization of discontinuity map. And as you can see in the second row here, the discontinuity map does a good job for capturing object like the UI here or UI minimap or playing buttons here. So this is the end of presentation, and please let me know if you have any questions. Thank you.
Awesome. Thanks, Lucas, for the presentation and the research. I think there was one question from Nahid on the chat. She asked, what software did you use to create the diagram in slide 21?
Sorry, can you say that again?
Yeah, she was asking, like, which software did you use for creating the diagram of the network in slide 21?
21.
Yeah, I think that was the slide where you display the Adakov architecture.
This?
Yeah.
In this architecture, what was your question?
Oh, she was just asking what software do you use to like create this diagram.
Sure. There are many questions. Yeah, diagram in the network in slide 21. Which software? I just used PowerPoint, Microsoft PowerPoint to make this diagram.
Yeah, that looks very impressive. But I thought it was like some sort of complicated arrow construction. Yeah. Yeah, any other question from the audience for Lucas about the details of his research?
Yeah, I have a quick question, and maybe you said it, but I was looking at your profile in the papers, and so I might miss it. So how does the algorithm, or how do the algorithm distinguish between the continuous and the discontinuous motion? Like, do you have to provide like the region, or does the algorithm recognize it automatically?
Yeah, the discontinuity map is trained end-to-end. So I don't give the model any other supervision or hint to distinguish the discontinuous motion. Just I let the model to choose if the model can choose the interpolated version or just the first input frame, and the model automatically learns to choose, learns what to choose from the two choices.
Oh, okay. Yeah,
Yeah.
I had missed that part. Oh, now it's clear. Thanks.
Yeah, thank you.
Maybe a question just about like the use cases application of like video frame interpolation. Can you talk more about like I think that example of the video games data set is like very good explanation of potential use case. But like can you highlight some other benefits of using these techniques for real application?
Yeah, video frame interpolation, it can be used for in two ways. So most of the videos are have 30 or 60 frames in a second when the FPS is 30, and just giving video interpolation to the video, I can make the 60 FPS or 120 FPS video, and this can be more smoother video. And this is the first application, and the second application is the case of fixing the FPS. So when I fix the FPS and just make more frames, and I can make slow motion video from the input videos. So these two were the main application of the video frame interpolation. And lastly, when I skip some video frames and compress it and then decode the video and then interpolate the skipped frames, I can get more high compressed rate for the videos. So the three are the main application of video frame interpolation.
All right. Yeah. Awesome. Thanks for highlighting on the technical point of view. I think, making slow motion from a long video frame, I imagine it's pretty useful for like, maybe like entertainment or media, right? And then compressing, getting more information, right, from a compressed version of the video. I think is super useful for video encoding technologies, right?
Yep. One more thing is that for in case of video games or animations, or if stop motion movie cases, each frame making or generating each frame is not simple. It is very difficult to make each frame. Like in animation, we should draw all frames manually, but using the frame interpolation, we can just draw the half of the animation frames we needed. So it can be one more application of video frame interpolation.
I see. Yeah.
Yeah.
Yeah. Animation. Great. I think that's a very unique and interesting use cases.
Yeah.
Perfect. Yeah. So we're at the top of the hour, and thanks, Lucas, for walking through your research publication and educate the audience with the complexity of video frame interpolation. I personally do not know much about this before I go, so I think it's definitely interesting to see all the in-depth technical challenges of making it making it work, right? Yeah, with that, I'll let the second speaker, Nir Gazit, to start his presentation. Yeah, so Lucas, if you can stop sharing your screen so Nir can get started.
Yeah.
Yep. No, yeah, feel free to start sharing your screen and go ahead with your talk.
Yeah. Okay. Great. So can anyone hear me? Everyone hear me?
Yep.
Yeah. So my talk is going to be more engineering focused. I'm going to talk about an open source that we recently released called OpenLLMetry. So first, I'm Nir. I'm the CEO of Traceloop. And today I'm going to present OpenLLMetry. It's an open source for monitoring of large language models and Gen AI applications in general using OpenTelemetry. But before explaining to you what OpenLLMetry exactly is, I probably need to explain what is OpenTelemetry. So OpenTelemetry is an open source protocol, an open source project that provides a standard way for reporting telemetries from production system and applications. We're going to explain in the next slide what exactly which telemetry this protocol supports. But the idea is that once this got standardized, all the major observability platforms basically align to it, and they're now fully supported. So from Dynatrace, Honeycomb, New Relic, Datadog, Grafana, you name it, everyone is supporting this open standard. So if your system is emitting the telemetries in this open standard, you can connect it to whatever platform you want. This project, as I said, is maintained by CNCF, which is the Cloud Native Foundation, part of the Linux Foundation, and it's one of the largest projects there. And when I say telemetries, I'm basically talking about three different things. OpenTelemetry defines logging, metrics, and tracing. So logging is, probably you're all familiar with that. If you've ever written some print in your code, then this is logging. So OpenTelemetry is defining a standard way for sending out these logs from your application. The second thing that OpenTelemetry is doing is defining a standard way for sending metrics. So if you want to measure some metric, how some metric behaves with time, for example, token usage, measure latency, check error rates, then you can use OpenTelemetry to report those metrics in a standard way, and you can connect it to any platform to visualize those or get alerts on them. And lastly is tracing. If you have complex applications, complex processes that contain multiple tasks, then you probably want to see how these complex processes are performing. You want to measure how much time each task took. You want to keep track of how the overall process is performing, and you want to see if there are some bottlenecks or some errors along the way. So you want to be able to visualize that and easily, and then OpenTelemetry also provides you with an easy API to report tracing metrics in a standard way. So to support all of the things that I've just mentioned, OpenTelemetry built an extensive set of SDKs. They're currently supporting 11 languages, and if you go to their their documentation, you can see like the supporting Python, JavaScript, Go, C++, like you name it, all the languages out there. And what they give you is this SDK is a way to report all the things that I mentioned, logs, metrics, and traces in the standard protocol. But that's not all, because you don't really want to manually create metrics or traces in your application. So there's an extensive library of what they call instrumentations. Basically, they automatically wrap different like commonly used frameworks, libraries, databases, and services, so that if you use them, then you get a pre-made set of metrics, traces, and logs that you can just plug into any platform and view them. So for example, let's say you're using some database like a MySQL database, and you're building an app in Python. So you're probably using SQL Alchemy. And then if you install the OpenTelemetry SQL Alchemy instrumentation, you get metrics around like query time, latency, connection usage, and whatever you want just out of the box just by installing that instrumentation. So it's pretty cool. And as you can hear, it was mostly like the protocol and everything that was built around it was mostly around, microservice, cloud-based environments. And this like ecosystem grew a lot in the past couple of years. The last component that is available in the OpenTelemetry ecosystem is for more advanced use cases. It's called the OpenTelemetry Collector. It's a separate service you can deploy in your environment, and it provides you with capabilities for post-processing of the telemetry before you send them out to whatever provider you use. So for example, if you want to mask or drop some PII data, or you want to not like send send some of the data and some data not send, like sample some of the metrics or traces that are produced in your system, then you can do it in the OpenTelemetry Collector pretty easily. And also, if you want to send the data out to more than one sink, then also you can configure the collector to do that, and then it duplicates all the telemetries and send them to both places or 3 places if you want. But we're not here to talk about OpenTelemetry. We are here to talk about OpenLLMetry. So what we did is we took the great infrastructure that was built with OpenTelemetry and we extended it to support everything that's Gen AI. So we've instrumented all the foundation models. We've instrumented many frameworks like LangChain, LlamaIndex, and Haystack. We'll also be supporting 12 labs pretty soon. And because we're using OpenTelemetry behind the scenes, you can connect all the data that we automatically instrument from all of these libraries, foundation models, and vector databases. You can just plug it into any system that you want. And you can even switch between systems, like whatever you want. For example, let's say you start and use Datadog for tracing your application, and then Datadog is getting expensive and you want to switch over to a different system. Then you just change some simple configuration in your application and you're connected to a different platform. It's that easy. And yeah, all of this is just the magic of OpenTelemetry. This is why I spend time talking about OpenTelemetry. It's a really great framework, and this is why we chose to build on top of it. And the idea is that you just get observability for your application, and you don't need to adopt any new tool. You can use whatever you're using today, and you can switch over between tools pretty easily. I think that's enough talking for today. I can just go over to a quick live demo. So I built here a really simple RAG pipeline. I've used LlamaIndex for that. I have here ChromaDB as a vector database. I'm using OpenAI. And what I'm doing here, let me just move the Zoom bar. Okay. So what I'm doing here, this is an example, actually like one of the first examples you have in the LlamaIndex documentation. I've taken, some essay by program. I've stored it in the vector database, and then I can ask some question about the essay, and then LlamaIndex behind the scenes, get the relevant information from the essay, from the vector database, plug it into the prompt and send it to OpenAI to get the answer to the question. Pretty standard RAG pipeline, pretty simple one. I'm running it now just to see if it works. And yeah, the question was, what did the author do growing up? And this is the answer that OpenAI provided based on the context from the vector database. So we want to see what's happening here behind the scenes. Let's do that. What we do, if we go to OpenLLMetry documentation, super easy. You just install the SDK, you initialize it, and that's it. So let's do it. I've already installed the SDK, so just need to uncomment this and uncomment this. And let's run it again. Now, as you see, we are exporting traces, and we'll be able to view them in our platform in this case. Great. Yeah, this is the trace from now. And it's pretty nice. You can see here everything that's happening. We created the embedding for the question. Then we call Chroma to get relevant vectors. Then we call OpenAI. And for example, for OpenAI, we can actually see the prompt that was sent and the response that we got. We also have some more data that we send in our instrumentation, like which model was used, how many tokens in the prompt, in the completion, and in total, and some other model configuration parameters that we've extracted. And this is all standard OpenTelemetry. So similarly, I can just go and connect it to any other platform. If you go to our documentation, then we have here a lot of things that we support, a lot of things that we natively integrate. For this demo, I've chosen, what was it? It's Grafana. I chose Grafana. It's pretty common as a monitoring platform among engineering teams. Here you have a guide of how to connect OpenLLMetry to Grafana. We'll take the simple path of not using Grafana agent and just directly connecting to Grafana from our application. There's a short guide here. I've done this for you. And basically, you just need to extract some parameters from Grafana. And then you just change two environment variables in your application. And that's it. So I've done it here. I have this in the file preloaded. So I'm just going to load another environment variable file. And I'm going to run it again. Of course, I forgot to save, so it sent it again to traceloop, but let's run it again now. And then, as you can see, it's exporting traces to Grafana, so we can actually verify that we are sending it to somewhere else. And let's wait for it to finish. Great. So go back here. Let's go to Grafana and refresh. Voila, the same trace is here with all the data available here with all the attributes, the completions, trace, whatever you want. Yeah, that's basically it. And as I said, like any other platform is easily supported, as you've seen. It's just a change of two environment variables, and you export your data to whatever platform you want.
Awesome. Is that the end of the presentation?
Yes.
Oh, yeah. Great. Well, thanks, Nir, for the demo. Yeah. So Nahid got a question in the chat. If everyone can answer it.
Yeah. So it is more for system metrics, not for neural network metrics, right? Yeah. This is more for applications. So more for like RAG pipelines, like complex workflows or chains that you have using LLMs or other generative AI models. It's less for like monitoring inference or training pipelines. This is less the use case that like the open source is focusing on for now.
Any other question from the audience on the product and kind of the philosophy behind OpenTelemetry? Yeah, I think in general, like evaluation, observability is a topic that a lot of people have opinion on. So yeah, perhaps from like your opinion, right? What do you think is how do you think the technology for foundation models observability is going to move forward, like for the next few years?
Sure. I couldn't hear you that well, so maybe.
So my question is like from your experience working in the space, like how do you see the evolution of like observability and evaluation tooling for Gen AI? Like what kind of approach do you think is going to win? What are the major principles that you think is like a lot of other companies is using, especially in well, both from developers as well as more from from like enterprise organization.
So I think you can say like that I'm a strong supporter of like open protocols. So I think that this is the way to go. And the thing is, like, if you look at classic cloud observability, then we started with like proprietary protocols which vendor locked you into a specific platform, like for your life. And then only like 10 years after came, these open protocols like OpenTelemetry that freed you and allowed you to switch between vendors easily. And then I'm coming from like a traditional, machine learning background, and I've seen a lot of like proprietary systems develop in this space as well. And I'll hope with like in the Gen AI space, we'll be able to early on, bring the openness, open protocols, open source projects to this ecosystem. And then, we'll get, other platforms just aligning with the open protocol. And we're seeing it today. Like I've been in touch with many like traditional observability systems, but also lots of companies that are building specifically for this space. And we're trying to align together on this protocol to make it easy for everyone to use it.
Yeah, and I guess now the question, I'm just curious, you don't have to share the specific details, but like from your slide, it looks like, and also from GitHub repo as well, it looks like OpenLLMetry has already integrated with like a lot of different foundation models vendor, as well as VectorDB vendors, as well as like orchestration vendors, right? Did you see any patterns of like what are some of the tools that are more popular within the open source community? Like do people choose Anthropic versus OpenAI? Do people prefer Chroma than like Python, etc.? It's just a very high level observation.
So it's like probably it's not like a survey, like a statistically accurate survey, but we've been seeing a lot of usage with LlamaIndex as a framework. Like a lot of people like using it, especially with our open source, but maybe just because LangChain has their own like a solution, Langsmith, and then for LlamaIndex there isn't any solution, so it's more natural for people to try us out. And from like model perspective, I've been seeing, of course, like 80-90% of the users are using OpenAI, and if they're combining other models, many people use Cohere just because of the more use case specific APIs that they expose that other providers don't have. And then the other model that we've been starting seeing more and more users are using is Google, Gemini, and also Bedrock from AWS.
Yeah.
And for the vector databases, Chroma is by far like the leading, as we've seen.
Yeah, that's super interesting. Yeah. That's super interesting, especially on Chroma and Cohere. I was thinking that they are more a bit behind, but it sounds like they are quite popular within the open source.
Yeah.
Another question I have is about sort of like how like existing observability tools fit into kind of what you're trying to do, right? So I think in one of the slides you were mentioning like Grafana, Datadog, New Relic. These are all like traditional, software monitoring tools for general software application, right? And it sounds like they do not really like tailor personalized for foundation models, right? And so can you elaborate a bit more on like how does OpenLLMetry, integrate with like some of the existing observability source monitoring vendors to to support for the Gen AI revolution?
So, for example, the tracing use case, the waterfall that I showed you before, is a really common use case. If you have like a complex pipeline, like a RAG pipeline, where you need to do certain tasks, sometimes in parallel, sometimes sequentially, and you want to be able to see what's happening in the system. But this is like a really common task, if you go back to like traditional cloud observability, and sometimes the tendency to like reinvent the wheel, but tracing is something that's been existed for a while, and sometimes if you just want to see a trace of your system, you don't need some new fancy tool. You can use the things that's been used for years, in like cloud observability. You just need the right adapter, and I think like this is what we do with OpenLLMetry. If you need to look at the trace, you can do it in Datadog, even though it wasn't meant to be used for RAG pipelines. It's perfectly, like, it's doing a really good job at like visualizing RAG pipelines and allowing you to debug them or monitor them in production.
Got it. Yeah, thanks for sharing that insight. Perfect. Yeah, if there's no other question from the audience, I think we can close out the webinars a little bit early. Yeah, thanks Nir for the great demo and the presentation. One thing to note that I think as you mentioned briefly is like, I think once 12 Labs got an SDK about technology out, would love to have basically integrate with OpenLLMetry for the instrumentation part, like provide logging tracing capabilities for our foundation models. So yeah, so excited to see that down the line. Again, yeah, we run this webinar on a weekly basis, and the recording of the session will be posted available on YouTube at some point within the next few days. Thanks everyone for taking the time to join our session today. Thanks to the two speakers for preparing your talks and sharing the insight with us. And yeah, I hope you have a great rest of your weekend. Thanks everyone. Bye-bye.
Thanks. Have a nice weekend.
Thank you. Bye.